Okay. Good afternoon, everyone. My name is Meredith. I'm a postdoctoral researcher here in ICRA. And today I'm going to talk a little bit about when is it really a drought. Now, for most of us who think that's a relatively easy question. However, drought is probably one of the most complex natural hazards that we face, especially in the advent of climate change. So I'm going to talk a little bit about why it's so complex and how we as scientists are able to quantify this complexity in order to use the data in sustainable management during a drought. So why is drought so complex? There is no universally accepted definition. This is because what counts as a drought depends where you are and what you do. For example, a farmer might not call a drought for 3 or 4 weeks with no rain, or a reservoir manager might not feel the impacts for 4 to 5 months. It's very difficult to identify over time. This is because a drought acts very slowly and invisibly, and sometimes we might not realize that it's happening until the impacts are already felt. There's no physical variable that we can measure. There's no drought sensor, unlike temperature or rainfall. So we have to infer droughts indirectly through indicators such as stream flows or groundwater levels, etc. Also, it affects economic sectors and natural systems differently. This is all related to water demand, where some economic sectors demand more water than others. Natural biomes, such as deserts, require far less water than tropical biomes, etc. So we can already see the complexity of droughts and how different aspects overlap. However, there's an underlying thread through all of this, and that's water demand in different areas. And if we understand that, we're able to identify drought easier. And one of those aspects is related to water balance. Now, in simple terms, a water balance is the amount of water coming in versus the amount of water going out. However, in natural systems, this is a little bit more complex, and we like to think of it as a water storage system. So when we look at it, primarily, rain is the major input into our water storage system. And as it falls to the ground, we have events that remove water from the system. For example, transpiration and evaporation, all related to temperature, extract water. Topography of the system would remove water through surface water flows or underground water flows. And then we have areas of retention, such as lakes and lagoons, or aquifers storing water in specific areas. So this is how we understand a water storage system. If we equate a little equation to this, and we say that the rate of change of storage over time equals 0, that means water coming in equals water coming out, and the system's in balance. However, if this value is negative, there must be a deficit where more water is leaving the system than entering. Therefore, we can start calling it a drought. So we take that principle and we look at the different aspects that contribute to water balance, and one of the primary ones as input is precipitation. And one of the most commonly used tools is the Standardized Precipitation Index, and the concept is very simple. We take precipitation data, we add a probability distribution to it, and convert the data to an index, usually between 0 and 5 or 0 and -5. And from there, we're able to produce a graph like that. And what that means is, if the value is 0, it means it's normal. If it's less than 0, that means it's drier than normal. And if it's greater than 0, it means it's wetter than normal. Okay, so now we're starting to get a clearer picture of when droughts are starting to occur. Not only that, though, but we're also able to determine the duration, the magnitude, as well as the intensity of the drought, if it's occurring. So this is primarily focused on precipitation. However, we remember that evaporation and transpiration remove water from the system. So the question is, if precipitation is the same, what happens if temperatures increase significantly, which we're experiencing in climate change at the moment? So we use a different index, which is the evapotranspiration index, where we use evaporation and plant transpiration in our calculations, and we get a more accurate idea of water demand in a specific area. Not only that, though, we're able to aggregate it monthly or annually to get a better picture over a long period of time. And the result is a graph like this. This is actual data of Girona from 1950 to present. The blue indicates wet periods, and the red indicates dry periods, and you can already see trends. Concerningly, since 2000, we're seeing an increase in frequency of dry events. And you remember Catalonia is experiencing a drought right now, and we can already see the magnitude and intensity that we're currently experiencing. So in conclusion, drought is complex. However, we're able to measure this complexity, and with this data, we're able to derive sustainable management plans for the future. Many thanks.